Assalamu alaikum. Dear students, today we are going to start third lecture of the first chapter, that is equations of motion. We are going to derive three equations of motion by graphical method. So we have actually three equations. One is V is equal to U plus AT. Second equation is S is equal to UT plus half of AT square. Third equation of motion is V square minus U square is equal to 2AS. These are the three equations. We can derive these equations. We have already drawn here a graph. We have plotted a graph between velocity versus time. And this is the graph. If you carefully observe this graph, you'll see this graph is actually for uniformly accelerated motion. We get a straight line because the velocity is changing uniformly. We get straight line. But from this graph, we can also interpret that the graph is not starting, since the graph is not starting from the origin, it is starting other than origin. It means initially body is having some velocity. We denote that velocity by u. So after that, when time was 0, body was having some initial velocity, that is u. After passing some time, let it be t time. So after t time, it acquires a velocity because the acceleration is changing. Acceleration is there, that is uniform acceleration. So velocity is getting changed, that becomes v after t time. So this we have completed here, the graph. This theta is the slope which the graph makes with the horizontal. So we have completed this triangle ABC then with this figure. So this is velocity versus time graph. Now let us take first equation, that is V is equal to U plus AT. Let us derive it graphically. So let us derive this derivation. Since this graph is, there's a straight line graph between the velocity versus time, that is uniform acceleration. So what we do in this, we know slope is always equal to, slope of this graph is always equal to mathematically tan theta. If you see here we have triangle, we have triangle. In right triangle ABC, tan theta is perpendicular by base. Perpendicular is BC, base is AC. So this is the right triangle. Here tan theta we got equal to perpendicular by base, that we got here BC by AC from this triangle. Now slope is always equal to tan theta, but we also know slope of velocity time graph, that gives acceleration, because we know when we find the slope of this graph, that will give us acceleration. So we can say A is equal to tan theta. We can say A is equal to tan theta. Now A is equal to tan theta. A is equal to tan theta we got here, that is BC by AC. Now see, BC is what? BC we can calculate here. We can calculate BC here. We can calculate BC here. That will be BD minus CD. BD is V minus CD. Since OA is U, this is also U. This is time. So it will be V minus U. So AC is what? AC is T. So we can substitute here V minus U divided by T. AC is equal to OD. Both are equal to time. So here we can cross multiply, we get AT is equal to V minus U. Now after transposing this term, we will get AT plus U is equal to V, or V minus U is equal to, or we can say V is equal to U plus AT. So this is the first equation which we have derived here. So first equation of motion we have derived. We got finally V is the final velocity, U is the initial velocity, A is the uniform acceleration, T is time for which this velocity gets changed. Now this was the first equation which we have derived. Now let us derive second equation of motion. Second equation is S is equal to ut plus half of at square. Since in this equation, left hand side, it involves distance term. S is distance. So whenever we have to calculate the distance from the velocity time graph, we basically find the area under this VT graph. So area under this VT graph will give us the distance. So distance is area under VT graph, velocity time graph. So we can find the area of this graph, that is area of triangle ABC plus area of rectangle OACD. Area of triangle, right triangle ABC, if we know, is half of base into altitude. Base is AC into altitude is BC plus area of rectangle, you know the formula, length into breadth, that is OD into OA. Half of AC is T, you know AC is equal to OD is equal to T, BC is equal to V minus U. Substituting here, AC is into, instead of AC we can write T into BC V minus U plus OD is T, OD is T into OA is U is equal to half of, so first we will write this term, U into T plus half of into T into V minus U. Since we know acceleration is V minus U by T, so it will be AT is equal to V minus U. Now we will eliminate here UT S is equal to UT plus half of into T into, instead of V minus U we will write AT. So we got UT plus half of AT into T square. So we have derived second equation of motion. The second equation of motion we have derived, this is S, this is the basically relation between the position versus time relation. So from this equation of motion we can find the distance covered by the body when body is moving with constant uniform acceleration. Now we have one more equation that can be also derived from the same graph, velocity time. Now we will find third equation of motion. Third equation of motion, that is V square minus U square equal to 2AS. Since in this equation there's also distances involved here, so we can find distance area under VT graph. So we'll take area of trapezium OABD. You know the formula of area of trapezium is half of sum of parallel sides. Sum of parallel side is OA plus BD into this perpendicular distance OD. So it will be half of into OA. OA is U plus BD. BD we have already calculated, that is equal to V. V into OD. OD is T. So it will be half of, we can write V plus U into T. And we also know acceleration is equal to V minus U by T. T will be V. Acceleration is equal to V minus U by T. T will be equal to V minus U by A. Because in this equation there is no T term, so we will eliminate this term. Half of into V plus U into V minus U by A. Now S is equal to half of this, basically we can write 1 by 2A into V plus U into V minus U. So this is the basic formula, basic identity of mathematics. A plus B into A minus U we can use here. So you can use here A plus B into A minus B, that's equal to A square minus B square. So here it is 1 by 2A, A plus B into A minus B, that is V square minus U square. So after cross multiplication, 2AS is equal to V square minus U square, or V square minus U square equal to 2AS. So in this way we have derived all these equations of motion. But remember one point, these equations of motion, they are applicable only to those bodies which are moving with constant uniform acceleration. If the object is having non-uniform acceleration, you cannot use these equations. These equations are only applicable for uniformly accelerated bodies which are moving with constant uniform acceleration. So these equations will help us. We can solve many numericals. For example, we have to find different parameters, distance traveled from the graph, or initial velocity, final velocity, acceleration you have to calculate. So you can use accordingly these equations. Whatever you require in the question, you can use these equations. These will help us to solve many numericals. So in this way we have finished this topic. Inshallah in next videos we'll start uniform circular motion.